At some point, every single one of you has contemplated the thought, what is infinity anyhow? How can you understand it? How can you imagine it? How can you wrap your mind around it? And how can you picture an endless sequence of numbers? A constant which never ends. A number that includes the phone numbers of all your acquaintances, the dates of birth of all the people on the planet, their credit card numbers, the designations of all known stars, and even the date of your dentist appointment. All of this massive series of numbers is contained in an amazing mathematical constant, the number pi. And despite the fact that it has been known since ancient times, to this day, pi stimulates the minds not only of scientists, but also of ordinary people. Those who first calculated the number pi can be considered prehistoric people who, when weaving baskets, noticed that in order to get the desired diameter, it was necessary to use a reed 3 times as long as the diameter. This fact was recorded on tablets made of baked clay that were found in Mesopotamia. Examples of accurate and not entirely accurate calculations of the number pi can be found in the works of Egyptian, Babylonian, Indian, Chinese, and ancient Greek geometers. So what is this mysterious number pi anyway? It is a mathematical constant that expresses the ratio of the circumference of a circle to its diameter. Many ancient scientists, including Archimedes, try to calculate pi each time by filling a circle with polygons that had an enormous number of sides, so they would more tightly fit within the area of the circle. Archimedes used a 96 gun. Chinese mathematicians fit in a 192 gun, then a 3072 gun, and finally they managed to fit a polygon with a 24,576 sides into a circle. This is why many mathematicians contend that a circle is a figure with an infinite number of angles. Up until the 15th century, only 9 decimal places were known. Isaac Newton calculated the number pi to 16 digits. As recently as the 19th century, it was calculated out of 707 decimal places. But with the advent of computers, this process has accelerated significantly, and now science has already identified about 50 trillion decimal places. Pi is irrational. Its decimal representation never comes to an end, and it is not periodic. Consequently, based upon the formula that the circumference of a circle is equal to pi times its diameter, the circle doesn't come to a close since there is no finite number. This fact can also be closely related to the spiral characteristics in our lives. After all, even the orbit of our Earth is not at all a circle. It moves in a spiral relative to the center of the universe and space-time. A logical question arises. How many numbers do you need to know in order to make a given calculation? Let's round pi up to the 15th digit. And as an example, let's take the farthest spacecraft from the Earth, Voyager 1, which is located at a distance of about 20 billion kilometers. Imagine a circle with a radius this size, in other words, a diameter of 40 billion kilometers, for which we want to calculate its circumference using formula 2 pi r. It turns out to be a little more than 125 billion kilometers. We don't need to put emphasis on the exact circumference. We are interested in the error of the measurement. So it turns out that the circumference using the constant rounded up to 15 digits is calculated with an error of less than 4 centimeters. Think about that. We have a circumference of 125 billion kilometers, and the margin of error is less than the length of your little finger. We can study the problem using the example of the Earth. The diameter at the equator is 12,756 kilometers. The circumference of the equator is 40,075 kilometers. which is the distance you'd have to cover if you want to travel around the world, not taking into account mountains, valleys, and obstacles like buildings, parking lots, ocean waves, etc. How wrong is your odometer when using a rounded-off value of pi? Its error is about the size of a molecule. Naturally, there are different kinds of molecules which do differ in size, but you get the idea. The size of the error is about 10,000 times less than the thickness of a strand of hair. Now, let's take the largest possible object, the visible universe. Its radius is approximately 46 billion light-years. How many decimal places of pi do you need to use to calculate the circumference of the universe with an error of no more than the diameter of a hydrogen atom, the smallest atom? You need 39 places following the decimal. If you think about how huge the universe is, well, and truly larger than we could ever comprehend, and such a tiny atom of hydrogen, you will then understand that a really accurate calculation doesn't require very many decimal places of pi. There is an abundance of surprising facts about this constant. Stanislav Ulam, a Polish-American mathematician, in 1965 wrote the numbers of pi out on graph paper. He put the 3 in the center and, moving in a counterclockwise spiral, wrote down the numbers after the decimal point. In addition, he drew circles around all the prime numbers. He was both surprised and aghast when he noticed that the circles were organized in straight lines. Then, using a special algorithm, the mathematician made a color picture based on this drawing, which is called the Ulam spiral. Seeing that pi correlates a curved object, a circle, with a straight object, the diameter, we can find it in all sorts of places. Some find the number pi in riverbeds, the length of a river, with all of its meandering bands, in relation to the straight line between its source and its delta, according to calculations, is on average pi. Models for virtually all wave-related phenomena will involve the number pi. Let's take light and sound, for example. Pi determines what colors are visible in the spectrum of a rainbow and how the note C should sound. The number pi is also observed in the process of the cells in apples acquiring a spherical form and in the brightness of the light output of a supernova. Well, perhaps the code of the universe is encrypted in this number. One of the moons of Jupiter, known as Io, played a significant role in the advancement of 17th century astronomy. Studies had shown that in the process of crustal compression, about 100 mountains were formed on the surface, changing the landscape over the next number of centuries. The peaks of some of these, for example South Busal Mons, exceed the height of Mount Everest twice over.